In this video, I'm going to show you how to use the formula for the confidence interval of the mean with a specific alpha when the standard deviation of the population is known. Really, this is just using this formula right in the center here, this video should also help you understand how to use z sub alpha over 2. Basically, I'm going to explain questions 10 through 20, 22, sort of 26, and it should also help actually with question number 9. So if you're confused on any of these questions, this should help, but it also should get you started. Now if you look at this equation, you of course start out with the sample mean right here, and you're going to add or subtract, depending on which side you're talking about, that z sub alpha over 2 that we've talked about. I'm going to get into that next. And then you just multiply by theta divided by root n, which came from last section. So as I said, let's talk about that z sub alpha over 2. Here it says if you want a 90% confidence interval, the z sub alpha over 2 is 1.65. 95% confidence interval, z sub alpha over 2 is 1.96. And like a 99% confidence interval, you'll have 2.58. So let's talk about that 90%, 95%, and 99%. Of course, you could have other confidence intervals besides that, but if you think about 90% confident, as we talked about before, that means you have 10% of leeway room that you're not confident about. So 0.05 to 0.95 would be the middle 90% though, because you're splitting that 10% on each side. So 5% from the bottom and 5% from the top for this middle 90%. So if we look for 0.95, well, let's figure out what we have that's closest. Both of these two are pretty darn close in the same amount, but as I mentioned in the earlier video, you're always going to go for the one that is higher. So because this other one is 1.65, we're going to go with 1.65. So if we look back at the last slide, that's where they got their 1.65 for z sub alpha over 2 of 90% confidence interval. Now back here, when we look for 95% confidence interval, remember we have to cut that as well, so we're going to now look for 0.025 and 0.975. So 0.975, there's actually right on the chart, and it's 1.96. So in the last slide, if we went back, it says 1.96 is z sub alpha over 2 for 95% confident. 99% confident, you do 0.995. Now really make sure on the test and when things come that you're splitting that 1%. So we're only 0.5% away from 100%. So if we scroll down, we're looking for 0.995. We're pretty darn close with a few of these, but these two again are the closest, so we're going to round up, and that's 2.58. 2.58 is for the 99% confidence interval. So now let's look at example 7.1. 7-2 is also pretty good, and it is in your book. Do note, so this question explains that a researcher wishes to estimate the number of days it takes an automobile dealer to sell a Chevy Aveo. The sample of 50 cars had a mean time of the dealer's lot of 54 days. Assume the population standard deviation to be 6. Find the best point estimate of the population mean and the 95% confidence interval. Well, the first thing that we want to think about is this 95%. As we found out on the last slide, 95% is 1.96. I didn't write it up here, so 1.96. So we're going to bring this 1.96 is equal to z sub alpha over 2 back here. And note again that z sub alpha over 2 is just one number. So if we look down here, they have the 54 as the sample mean because it explains has a mean time of 54 days. 1.96 is plugged in for z sub alpha over 2. It says the standard deviation is 6, so that's plugged in. And then the square root of 50 is down here because n, the sample of 50, is 50. So all the equation is done out, and then basically you're done at that point where you find out that the population mean is between 52.3 and 55.7 with a 95% confidence interval. If you want to go further, I'm going to go over questions 10 and 11, which are going to be, at least one of them is going to be classwork tomorrow. So just check out the other video for an actual question from what classwork is going to be on, and you can get classwork started already.